Okay. Today's presentation will be about sprinkler pump or fire pump curve and their setting, and we talk a bit on the orifice plate for sprinkler pump. So let's start the presentation. Okay. Just now I tried recording, it doesn't work. So this is the second time I'm doing it. So we start from the beginning. Okay. This is just pump curve that actually I picked up from MS 1910. So this is just to show you the starting. Okay, here is actually from MS 1910. So normally fire pumps, how do they work? So the fire pumps, actually jockey pumps, we don't consider them fire pumps. So things like duty and standby pumps, we consider them fire pumps. So for all the duty and standby pumps, for example, we have wet riser, we have sprinkler, and then you also have hydrant. We only have cut-in pressure, there's no cut-out pressure because the pump cannot be stopped manually. It cannot be stopped automatically. It must be stopped manually. It can only be stopped manually. So that means that you don't need any cutout pressure for your sprinkler and wet riser pump. So if your sprinkler and wet riser pump got cutout pressure, then it's wrong. Your concept is wrong. So you see that for sprinkler pump, your pump is not only required to supply your design flow rate at your design pressure, you must also ensure that at 140% of the flow rate that you have, let's say this is Q, this is 1.4 Q, you must achieve at least 70% of your P. So this is one thing about the sprinkler pump. So your sprinkler pump must be able to pass this point and this point. If it doesn't pass these 2 points, actually it does not pass the standard and the pump must be rejected. So what does MS2616 say about pump? So MS2616 does not address pumps as sprinkler pumps, they address pump as fire pumps. So in MS2616, actually it says that your pump shall produce heat not less than 80% at 130% flow rate, no longer 140%, here 130, just now 140% for your sprinkler. So the other one is that your PS here, which is the shut-off heat, must be smaller than 140% of the duty head. This is called duty head P. So it must be smaller than 1.4 P. The other guideline it gives you is what is your test pressure for your pipeline. So test pressure is you need to test it at minimum 14 bar, which is 200 PSI, or 4 bar in excess of your shut-off pump, shut-off pressure PS, plus the static available at the incoming suction pipe. So it's actually what your pump can do, the shut-off pressure plus your static at the incoming suction pipe. So that you set already your hydrostatic test, but there's no mention of what is the pass criteria. You only know what is the test pressure you need to set. So there's no mention on how you set your pressure. Your pump pressure setting is no mention. So we assume that it's similar for your wet riser. We assume that it's similar to sprinkler pump, how you set the thing. So the next thing is that, okay, since that we don't have any guidelines in 1910 for sprinkler and 2616, so which is for fire pumps. So we actually, and there's none also, I think, in BSEN 12845. So we go to Guide to Fire Protection Malaysia. Guide to Fire Protection Malaysia says that your duty pump is set at 0.8 PS. 0.8 PS means PS is referring to shut-off pressure. So a lot of people wrongly set to be 0.8 this P pressure, which is not correct. Then your standby is at 0.6 PS. The other thing that's mentioned is the jockey pump. So the jockey pump has to maintain at the control valve 1.25 times multiplied by static pressure difference. That means it's the height difference between the valve and the highest point. So there's no mention on the flow rate. So you know that your pump, jockey pump, has to stop at this. This is your stop level for your jockey pump. Then if your pump curve actually follow MS2616, let's say PS is not more than 1.4 P. So let's say your PS, let's say you get your pump curve, your PS, for example, if your PS actually is 1.4 times your P, so your duty cut in is 1.12 times P because it's 1.4 times by multiplied by 0.8. Your standby pump shall be cut in shall be 0.484 P. So you can see that the error, if you set this to be 0.8 P, that's actually there's actually an error here. So please note there's no cutoff pressure because a pump is supposed to be stopped manually, not automatically. So that means that your fittings, all these things is subjected to this pressure because there's no cutout pressure. So the pump will continue to operate. So let's say if you close the valve or whatever, all these things, it will run up this pump curve until it hit PS. So all your fittings must be able to withstand your PS. So you always check, the other thing that you need to check is that the static head to the highest floor level, that means it's between the pump and to the highest floor, must always be less than pump cut-in pressure. So because if it's more than pump cut-in pressure, the static head is always there. So your pump will never cut in. Otherwise, the pump will never cut in. And the other thing you need to check is that the jockey pump start, let's say you have a jockey pump stop. And then from your jockey pump start, then you can set your jockey pump start to be a bit lower. It could be 5 psi lower than the jockey pump stop. From there, you need to check that your jockey pump must be actually higher than your duty pump start. If not, what you need to do is that you need to set your jockey pump again. Maybe you need to set it to higher start pressure, and your jockey pump stop also you need to set to higher stop pressure. So this is the way you should go. So that one, let's say, is mostly for sprinkler. So what happened is that if this is for sprinkler. So this actually, I show you an example, is actually the wet riser. Let's say for wet riser, we follow the same standard as your sprinkler. So we always also check that the static head to the highest floor level, from here to here, let's say the highest floor level is 44 meter. So the static is 4.4 bar. So your cut-in pressure must not be less than 4.4 bar. That means it must be more than 4.4 bar. Otherwise, your pump will never cut in. Here is a Singapore standard. So I just go briefly. Singapore standard is a bit like American standard. So actually, it's actually the pump cut-in for the duty is actually very close to PS, which is 0.95 PS. And then your pump, standby pump starts when duty fails, but it does not tell you how you detect when the duty fails. So the jockey pump sizing is given here because it says that it must be less than 2.2 IGPM. Is for sprinkler SS575. So next thing we go to NFPA standard. What does NFPA standard says? I like NFPA because they are actually methodological. So it's actually step by step, because when you set all these things, all the pumps are related to each other. So the first thing you set is your jockey pump stop. So jockey pump stop at PS here plus whatever static that you have at the incoming of your sprinkler duty pump. So that should be your jockey pump stop. So once you have your jockey pump stop, the pump start, jockey pump start, you set it 10 psi below that. And then your duty pump start, 5 psi below your jockey pump start. Standby pump start, 10 psi below duty pump start. So it's actually very like all related to each other. I like this because I understand better. What pressure test you need to carry out on your pump? So at the pump discharge side, so it must be minimum 14 bar. So this is hydrostatic, is meaning is the pressure test for all your pipeline and your fittings, or 50 psi, which is 3.4 bar above the maximum discharge pressure. Let's say your static here, all these things, static pressure is 0. So maximum discharge pressure is PS plus 3.4 bar. So whichever is higher, you take that. So how you size your sprinkler jockey pump? So the sprinkler jockey pump shall be sized that is actually to prevent the duty pump from running when there's a one sprinkler head burst. So you to get the flow rate, you need to calculate the flow rate. But the flow rate shall also be not less than any allowable leakage. So I do not know what's the allowable leakage. So that means we really need to check NFPA 13 for the allowable leakage for the sprinkler pipe. So one sprinkler head, say, let's say for OH3, K is 80. So P is 1.2 bar. So Q is 88 liters per minute. So your jockey pump actually must be smaller than 88 liters per minute or 20 IGPM, for example. So the last slide here is for NFPA 24 private hydrant. So private hydrant, that means it's not hooked to, your hydrant is not hooked to a public line. So actually you have your own pumps or this. So this is for underground system, because underground system, I think there is a certain allowable leakage. Above ground is as a certain allowable leakage, but most of the time the hydrant has got underground pipe, so we use this. So this is the types of pipes that you can use for underground, but it's actually for NFPA. So in Malaysia, we only use ductile iron and MSCL. Hydrostatic test is the same, 14 bar or 3.4 bar in excess for system working pressure. So system working pressure is the same. It's actually your PS. So this is your acceptance criteria. Not pressure drop is not more than 5 psi, which means that it's 0.34 bar for 2 hours. So where do you put your gauge, all these things? You actually put your gauge at the lowest point of the system, or the portion of the system being tested, the gauge at one of the hydrant outlet that is tested. So let's say that means if you open whatever a certain part of your hydrant outlet. So most of the time we just use the lowest part of the system being tested. That is quite easy. The next thing you need to do is to find out what is the allowable leakage, because the pipes actually there is a minor leakage. So what actually leakage is allowable? So you need this. So here L here, this is actually in liters per hours. S is length in meters. D is nominal diameter in millimeter. P is average test pressure in kilopascal during hydrostatic test, which is here. So the next thing is that this leakage rate, what do you use it for? You use it to size your jockey pump. So your jockey pump should be sized to be able to make up the allowable water leakage within 10 minutes. So within 10 minutes, all this thing, it must be able to keep up with this thing. Or 1 IGPM, whichever is larger. So you need to check that. The last thing that I want to add in is just a bit of our understanding why we need orifice plate. So this, for example, what happened is that, let's say your highest floor is 45 meter, and then your lowest one is like 0 meter or this. So what pressure you have? Excessive pressure is 4.5 bar. So you need to calculate what is your flow rate, what is your pressure at the highest point, and what is the pressure at the lowest point. So at the lowest point, this is control. This is the pressure at the control valve. You need to minus. For OH, you need to minus off 500 millibar. Remember the 500 millibar pressure drop that we do. So this one actually will be available actually in my detailed webinar where we go through the calculation. So pressure at the lowest point is 1.7 bar, but now you need to add in 4.5 bar minus 0.5 bar. So now you need to actually calculate is how much water if actually all the sprinklers in your amount area actually activate. So your sprinkler, your flow rate at the sprinkler at the highest is 80 multiplied by square root of P, which is 1.2, 1.7 minus 0.5, 1.2, so you get 88 liters per minute. So here 216 meters square, this is your design area, divided by 12 meters square per sprinkler, you got 18 points, multiplied by 88 liters per minute, you get this 1584. So now you do another calculation at the lowest, 80 multiplied by square root of, now here, you have this, add this minus 0.5, you got 5.7 bar, you got 190 liters per minute per point. So this is almost like double. So which means that because before that you have 88 liters per minute. So your flow rate, your amount area is still the same. So your number of points is still 18. 18 minus 190 is 3420. So 3420, all these things might actually be beyond your pump curve. So that one we have to be careful. That's why we always, if possible, we downsize the pipe at the lower floors. And if we still get a very high static gain, all these things, so we need to stick in orifice plate to make that the static gain is acceptable, not too high, by injecting a orifice plate. So that's the end of the slideshow. So I stop this recording now.